A body starts moving from rest with constant acceleration, covers displacement in s1 in first p minus 1 seconds and s2 in first p seconds. So let's try to recollect the facts, the concept that we have learned in the previous section, which were difference between Sn and Sn. So it is given that it covers in the first p minus 1 second. So if you have, if you come across doubts like this, just replace this with say 5 seconds. So when we say first 5 seconds, what should come into your mind? It should be S at t is equal to 5 second, right? And how will Sn sound? It would be say displacement in the what? In the 5th second, right? That's the difference between S t is equal to 5 and S 5th. Okay, right. So similarly, what we have here is p minus 1 seconds, which means we basically have S p minus 1, which corresponds to S1. Okay, so S1 represents ut plus half at square. Okay, and Sp minus 1 represents I'm sorry, my bad. It should be S is equal to ut plus half at square. Yeah, and what is it's given S1 and S2, right? S1 and p minus 1, S1 in p minus 1, and S2 in p seconds. Okay, let me just clarify this thing. So we have S1, which is distance traveled in p minus 1 seconds, and then we have S2, which is the distance traveled in p seconds. Okay, excuse me. So I think throughout I have used the notation Sp minus 1 and Sp. Anyway, that corresponds to S1 and S2. Okay, now what is S1? Sp minus 1, which is equal to half a into, instead of t, we have here p minus 1 second, so p minus 1 the whole square. Similarly, Sp means S2, which means distance traveled in p seconds. So t will be replaced by p, which gives p square. Okay. Now, if you add these two, Sp minus 1 plus Sp, which essentially means if you add S1 plus S2, what you get is half a into p minus 1 the whole square plus p square, right? Why? Because you're adding these two equations, right? Now, if you expand this, p minus 1 the whole square is p square plus 1 minus 2p plus p square. So this becomes p square plus p square, which is equal to 2p square plus 1 minus 2p. Now, see this sp1 minus s2, right? This also is a distance, right? This also is a distance, say we call it st, along the motion of direction, right? Which means this also should satisfy the equation. This should satisfy all the equations of motion. Which means I can write St is equal to half at square, some random t, unknown t here, right? Now, if that is the case, can we equate these two equations? Oh, sorry, can we equate these two expressions? So we can say that half at square is equal to half a into p square plus 1 minus 2p plus p square. Okay? Therefore, from this equation, we can say that 1 by 2 is 1, a by a is 1. So what we get is t square is equal to p square plus p square is 2p square plus 1 minus 2p, which means t is equal to root of 2p square plus 1 minus 2p, which gives us the correct option as, I don't have the rest of the options here. Okay, option A.